Hello, chemistry student. Welcome to Displacement Note. So for those of you who are at home, you'll be watching this. And for those of you who are in school, you'll be seeing me doing this live in person. So displacement is a vector quantity. A vector quantity has a magnitude, a number in the unit, and a direction. Okay. So whenever you talk about anything that is a vector quantity, it will always have a number, a unit, and direction. For example, if I walk 5 miles east, that's a displacement. Or if a plane was flying 2,800 miles per hour south, that's a velocity. Both of those are vector. So vector always have a direction, and we draw them using an arrow. Okay. So once again, if you already know this in math, good. If not, I'll teach you how to use the Pythagorean theorem. But it said that any right triangle, that means a triangle that has a square corner, the two sides square added together would be equal to the hypotenuse or the diagonal side square. Basically, if you know the two sides of a right triangle, you can figure out the diagonal part or the hypotenuse. We'll be using this equation in class. Okay. So once again, this is a similar question that I've done in the past for distance. And here we just want to note down the key information. So we went 4 miles north, 3 miles west, and 5 miles south. And I jotted down on my note. So when I have that jotted down, that's my key data. And now we have to graph it so we can plan out the path and calculate the displacement. Okay. So plan out the path. I'm going to go 4 up, which is north, 3 to the left, and 5 down. So that means I cannot start at the top of the paper or the left side. I might want to start on the right side of the paper. And I went down more than I went up, so I might want to start, say, here. And I went 4, 1, 2, 3, 4, north. Okay, and I went 1, 2, 3, west. And I went 5 south, so I went 1, 2, 3, 4, 5. Now, as you can see, Mr. Wu hand is not very steady today, so I'm drawing a line that's not perfectly straight, but that's fine. Okay, and now that is my distance because that's my total path, and that is 5 miles. But my displacement is not the same thing as my distance. It's not the whole path. It's just a straight line from the beginning to the end. Okay, and because it has a direction, I want to make sure I draw it as an arrow. So this is our start and this is our end right here. So based on that equation that we wrote down earlier, we're going to be able to figure out this blue line right here if we know the two sides that forms this triangle. And looking from this long line right here looks like it's the same as the 3 mile. And then this one right here looks like it's just one line. And based on us, one line was 1 mile, so this is just 1 mile. So the equation we had written down was C equal to square root of A squared plus B squared. And it does not matter which green side you pick as A or B. So the two sides of the triangle, it doesn't matter which side you pick as A or B. So displacement, C, is now equal to the square root of A squared. So let's just say 1 mile square plus B square, which is 3 mile square. So C is still equal to the square root. Now we punch that out on a calculator if we need to, but 1 times 1, which is what the word square means, is still 1 mile square. And then 3 times 3, which is 9 miles square. Okay, so we can see that C is equal to the square root of 1 plus 9, which is square root of 10 mile square. And the square root will cancel out with the square, and we punch that out on the calculator. So C is equal to the square root of 10. So I punch out 10 on my calculator and I hit the square root button, or the square root and then 10. It gives me 3.16. For class, we only need to keep 2 decimal places of accuracy. Now, what's the unit? Well, the square root of mile square is still mile. And because we said vector has a direction, let's look at it. Our thing is going down and east. Okay, so it is actually down and west. I'm sorry, down which is south, and then to the left, which is west, so southwest. Apologize. Okay. Same here. Read, underline what you need to know. And then transfer that over to the graph as data. So 5 east and 4 south. So I plan out my trip. If I'm going east, I'm going to the right. I do not want to start with the right, and I'm going to go south, which is down. So I do not want to go down. I want to go the opposite of the right, which is left, and the opposite of down, which is up. So I start somewhere up here. Okay. And here I went, let's see, 5. So 1, 2, 3, 4, 5 east. And then 4 south. 1, 2, 3, 4. So that was my start. This is my end. Okay. But what is my displacement? The black line is my path, but my displacement is an arrow from the beginning to the end. So just roughly, not perfectly straight because I'm not using a ruler right here. So my displacement is that blue line, which is to the south and to the east. Okay, so now let's follow that direction again. C is equal to the square root of a squared plus b squared. So now we plug it in. C is what we're trying to find, square root of a. And it looks like, because this makes a perfect triangle already, we already know the two sides is 5 meter square plus 4 meter square. Once again, it does not matter which one is A or B. So C is equal to the square root of 5 times 5 is 25. And 4 times 4 is 16. So C is equal to the square root of 25 plus 16. 5 plus 6 is 11. Plus 10 is 21. Plus 20, 41 meter square. Okay, I'm just double checking with my calculator. And now C will be just the square root of 41. So I go 41 square root or square root 41. And my calculator tells me 6.403. So I can just go 6.40. Now meter square is square root, so it becomes meter. And the direction of our arrow looks like it's going down and to the right. And down and to the right is south and east. And we circle our answer in math, so people know that's a final decision. Last one. Now this one, we're going to use a key to tell people that one line is not just 1 mile. So once again, we have our data, 20 south, 25 east, and 30 north. Okay, so let me go with a different color pen. 20 south, 25 east, and 30 north. And these are all miles. Okay. So with that, let's plan out our path. I'm going to go south, which is down, east, which is to the right, and north is up. So I might want to start on somewhat the mid-upper left-hand side. So let's just try to see if it works. 20. And now, Mr. Vu, I don't have 20 boxes, so what can I do? So I might say 1 box equal 5 miles. Okay. Because I have in multiple of 5. So 20 south would be 1, 2, 3, 4, because 4 times 5 is 20. 25 east would be 5, right? Because 5 times 5 is 25. And 30 north would be 6. 1, 2, 3, 4, 5, 6. Ooh, I got lucky. I ended right on the spot. Okay. And this is our start. This is our end. This is 30 miles. This is 25 miles. And this is 20 miles. And now we draw a hypotenuse, or the vector, I'm sorry, that represent our displacement. So now, once again, c squared. Sorry, actually, we've been using that equation, not the full Pythagorean term. So c equal to square root of a squared plus b squared, and a squared plus b squared. Now we have to determine what is a and b. So let me grab a different color pen. So it looks like our triangle And mix up that blue line is those two red lines. This one has 2 boxes, so that's 10 miles. And this one has 5 boxes, which is 25 miles. So that will be our a square and our b square. So c equal the square root of 10 mile square plus 25 mile square. C is 10 times 10 is 100. 25 times 25 is 625. So square root of 725 miles square. Now remember, you can use a calculator to punch it out for you to see. So now what is C? I have to take the square root of 725. So I go 725 square root. And my calculator tells me 26.925. So 25 would round up to a 3. The unit would be mile again because there's no square when you take the square root. And it looks like that thing is going up and to the right. So up is north and to the right is east. So the direction is northeast. You always mention north-south first and then east-west. So that's how you use the Pythagorean theorem to find the displacement.